Good morning everyone, welcome to another video here on the AviationPro channel. Welcome to the mighty Boeing 777 for Microsoft Flight Simulator made by PMDG, a wonderful airplane. And in today's tutorial we're going to take a look at how to start up this airplane from cold and dark. Now I've made a video on this already many years ago in the prepared version, but in the meantime I've gained some real world knowledge. I am actually currently a second officer in real life on the Boeing 777 and 787. So starting up the airplane is something I do quite a few times each month. Albeit not all the way from cold and dark, but still it's a very nice way to get to know the airplane, just to slowly get started, and that's exactly what we're going to do in this video. We're just going to take it slowly, take it step by step, and take a look at all the systems as we pass all the scan flows through the cockpit. For today's flight we're going to simulate a flight from Amsterdam to Los Angeles, KLM 601, and a nice flight all the way up north over Greenland, and yeah, we'll just have some fun exploring the aircraft as we program everything in and review all the knobs and switches. So I'll give you a little bit more detail as to the why we do certain things, or why certain switches are in certain positions at moments in time during the startup process. Alright, so without further ado, let's get started, but a little bit of a disclaimer first. So as I said, I am a second officer on the Boeing 777 and 787 in real life. This video of course will be a little bit based on real world procedures. However, some things have been left out here and there due to various reasons, so it might be a bit different here and there from what we do in real life, also due to the simulator limitations and the limitations of the PMDG 777. The procedures I show you here therefore do not relate to my airline or to the airline used in this video, or any other airline for that matter. It's just a tutorial tutorial for flight simulation purposes, nothing more, nothing less. So this video is here to get you going with the 777 in as realistic manner as possible within the limits of the flight sim environment. If you happen to fly this beautiful bird in real life, do not use this video for real world training purposes. Always consult with the manuals of your own operator. Alright, with that out of the way, let's take a look first of all how we get the PMDG 777 in a cold and dark state. As you can see, we are nicely parked here at gate Echo 19 at Amsterdam Schiphol Airport. And getting the cold and dark state is very easy. You go to the CDU right here and go to PMDG setup, and then go to panel state load, and one of the panel states is cold and dark. Now I did find that it's not the most realistic panel state for a cold and dark scenario, so I've created a custom one right here. You can find a link to that in the description with some installation instructions. So this is the one that I'm going to be working from in this video. If you will choose any other cold and dark state, or maybe some other cold and dark states, panel states that are out there, it should all work. I mean, we're going to pass everything, but this is the one that I'm going to use. So simply click on the line select key and then hit the execute button. Give the aircraft some time to load the panel state, and there we go. As you can see, the aircraft turns fully cold and dark right now. So as you can see, it's fully cold and dark here on board the Boeing 777, and the first thing we always want to do is get some electrical power on the airplane, and for that we use the electrical power up procedure. Now there's going to be some things that we have to check before we establish electrical power. First thing we do is turn on the battery switch. As you can see here on the electrical panel of the overhead panel, it's over here. We simply turn it on, and what it does is allows for some operation to either start the APU or also get external power. We'll be using external power in a moment. Of course, we do not want to drain the battery, so we need to have some sort of power source like external power or the APU. But first we check a few switches. First of all, the C1 and C2 primary hydraulic pumps need to be off, and all the demand pump selectors of the hydraulics must be off, which they already are, as you can see. This is to prevent any hydraulic parts moving on the airplane as soon as we establish electrical power. Then the wipers, make sure that they are off on the left side and the right side. This is to prevent wiper operation on a dry windshield. It could cause scratches on the windows. Then make sure that the landing gear lever is down right here. And then we move a little bit to the right here. Make sure that the alternate flap selector right here is off. and then we will be ready for establishing electrical power. For this we need to hook up some electrical power on the airplane. We do this in the PMDG 777 by holding the menu button in this cold and dark state. It will make the CDU come alive so we can access the FS Actions menu. I'm going to click on ground connections, and then we're going to request ground power. Okay, so if we look up right now, we see that there are two available lights. The 777 has two external power sources, which we are both going to use today. And if the available light shows, it means that the ground power is successfully connected and that the quality is acceptable for use. So we're just gonna hit primary external power. There we go, and also the secondary one. There we go. As you can see, some more lights on the overhead panel illuminate right now. And other than that, not much is going to happen yet, except for that the aircraft in the background is going to start up its systems. Okay, so we're going to give it some time. It's going to take some time. In reality, you would also hear some fans going up and down. Unfortunately, that doesn't seem to be simulated here in the PMDG 777. But soon you will also see some displays flicker. And yeah, we're just going to have to give it some time. Do not touch anything, just let it do its thing. So over time, more and more displays will come alive. You can see some of the CDUs now brightening up. There we go. Soon we'll see some of the displays flicker and come on. There they go. This is all normal part of the startup process, so don't worry. Just let it do its thing. There we go, and that's what you heard. It was a bit of a weird noise, but that's just the speaker system testing itself. And yeah, as you can see, the displays have come alive. All the radio panels, all the CDUs have come alive. And the master warning light shows when it disappears. Yeah, basically, the initial startup process of the 777 has been completed. So very nice. So we've now established electrical power, and from here on we can move on with programming and scanning the airplane. So imagine for a moment you just walked into the flight deck, and this is kind of how you would encounter the plane most of the time. Again, depending a little bit on the airline and the operations of the airline. But from here on we will continue with the preliminary pre-flight procedure, and this is kind of a procedure to check a few items and to yeah, make sure we have everything we need. You can check some of the safety equipment like the life vests, the emergency escape rope on board of the airplane, fire extinguisher, smoke hood, all these kind of things kind of would be checked in real life to make sure they are operational and actually there. And then we'll just check a few items here on the overhead panel. There are some guard switches and maintenance guard switches. Make sure they're all closed. If any of them would be open, you would have to contact maintenance personnel to make sure the switch is in the right position. We have some cargo temperature selectors right here for the aft and the bulk cargo. Now, depending on the type of cargo you carry, like any maybe live animals, maybe some flowers or fish, whatever, you can set a certain temperature range, or low or high. In this case, we'll just leave them as low, but if you want to simulate any of that, you can do that. Towing power and ground test, make sure that all these guard switches are closed. Now here we have the voice recorder. We're just gonna give that a little test. First we turn on the voice recorder here on the overhead panel. This switch will move back to auto as we start the engines. And we're just gonna hold and push the test button, and it will move the needle in the green range. It's a bit hard to see, but this shows you that the cockpit voice recorder system is working. Take a good look over on the circuit breaker panel. Now this is not simulated here on the PMDG 777, but it's good to make sure to that not any circuit breakers are popped that you do not expect to be popped, unless there's some maintenance item that is still open. One of them can be popped, but just give that a good scan, but all seems to be in order. Now in the back here you also have some oxygen masks for any observer pilots, so you can give those a little test. Make sure you see the yellow cross and that the oxygen masks are on 100%. You cannot really change that right here, and make sure that the doors are closed. There's one more over here of course as well. And yeah, let's take a seat in the captain's seat right now. There we go. There are a few other items that we're gonna have to check here. Now the ICAS display on your 777 is your friend. It shows all kinds of advisory, caution, warning messages about the airplane. Now it's normal to see some of the messages right here because the airplane is not started up, but it's good to kind of scroll through them, especially if there are multiple pages. You can do that using the cancel recall switch, or you can just remove them or recall them by pushing this switch over here. So you can check all what's over there. It's kind of good practice to keep this ICAS clean, so that if anything new pops up, you are made aware of it. Okay. Now these are some memo messages of the ICAS. These are normal messages, so don't worry about that. We are going to check the status display. Status, if there's anything wrong with the airplane, it would be indicated here. And yeah, you just have to check that. TCAS at the moment is not working, for example, but that's normal at this stage of the flight, so we don't have to worry about that. A few other things we're going to check is the hydraulics. We make sure that we have enough hydraulic quantity on board. If any hydraulic quantity is missing, it would indicate so by a refill symbol or a low symbol, so then you would know that some hydraulic refilling is required. In this case, it's plenty. The crew oxygen for the oxygen masks, a certain amount of PSI. I can tell you this is a well high enough value for your flight. Okay. What else we're going to check here on the engine page? So we're going to use here the display select panel to select the engine page. Make sure you check also the oil quantity, very important, especially for ETOPS flights, that the engines have enough oil in them, and anything above a level of 20 is usually enough for a long haul flight. Now if you want to, you can also do a little fire test. There's a little button over here to test, for example, the fire system and indications for the APU and the engine's fire. As you can see, they light up normally, so that is all working. It's also kind of good practice, once you get into the seat, to turn on some of the radios, especially if you're on VATSIM. You want to make sure you're actually, of course, select a proper microphone, and in real life the flight interphone would be nice to have that on the speaker to make sure that we can hear the ground crew when they call us. And on this radio is configured for data, which helps with uploading the flight plan through ACARS in a moment. If another frequency is selected right here, I'll just quickly show you how you can tune it. If data is not tuned on the VHF center radio, you can simply go, for example, to the lowest frequency, and then if you give it one more notch, it will automatically switch to data, and then you can put it in the active. So now this VHF radio is configured for a data transmission as well, okay, which is handy to have if you want to uplink your flight plan. So that's most of the preliminary pre-flight done. Of course, in the real airplane you would also check any of the documents of the airplane, make sure any maintenance items or that are still open are reviewed, and of course to make sure that the exterior inspection has been completed and signed off for your ETOPS flight. One last thing we're gonna do is switch on the ADIRU. Now the ADIRU is kind of the brain of the airplane in terms of determining its position in space and its attitudes, and it's good to practice to kind of realign the ADIRU system, because over time as you fly it builds up errors. Of course these errors are also mitigated by updating the position using GPS signals or radio signals from VOR stations or DME. But before every flight, it's good practice to give this a full realignment, and you can give it a full realignment by making sure that the ADIRU switch has been turned off for 30 seconds, which by the way stands for Air Data Inertial Reference Unit. Make sure it has been off for 30 seconds, and then after that you can turn it on again, and this will start the realignment process, and we're going to give it a valid position in a moment. So make sure you turn it on and make sure that the on battery light is extinguished, because if this one is discharging the battery, it will discharge the battery quickly. You will also hear a warning on the ground, a little horn to warn the ground crew that the ADIRU is running on the battery, but in this case we have established external power, so that is all okay. Alright, so that completes the preliminary pre-flight procedure. Alright, next thing we're going to do is the CDU pre-flight procedure, and that's to, of course, get the flight plan on board of the system. Now, what I first always like to do is make sure that I actually load the airplane with the correct amount of fuel and payload as calculated by my flight plan. Now, I've calculated flight plan using SimBrief. SimBrief is, I think, commonly used by a lot of people. If you don't know how it works, there are plenty of videos out there on how to create a flight plan with SimBrief. But SimBrief will spit out some nice fuel and payload values that we're going to be using for this long flight. Through the FS Actions menu in the PMDG 777, we're going to load some fuel. And as you can see, we have currently a block fuel. The total amount of fuel we're going to take with us for this flight of 89,519 kilograms. So we'll round it up to 89.6. There we go. Just enter it in the total and then it will automatically distribute it among the fuel tanks. And we're also going to load a payload, and of course you can also do this maybe through the GSX stuff or through the PMDG loading system, so it kind of accurately loads the weight over time. But I just like to personally just set these values to make sure they are correct. So we have an estimated zero fuel weight today of 206,517 kilograms, so I'm going to round it up to 206.6. There we go, and as you can see, it will just distribute that automatically. Alright, so that is the weight and fuel all set, so that's done and dusted. So we're going to start off by hitting FMC, and the CDU will follow quite a logical order, so don't worry too much. It's going to be a bit overwhelming, but we're just going to take it step by step. You always start with the ident page, and here you can see the model of the airplane, the engine rating, the navigation data that's on board, and whether that navigation data is still valid. So as you can see, it is now active, and this is corresponding to the current date. So we're within these dates. If there's a new AirRock data, then you would have to update this. You can do this by getting, for example, a subscription through Navigraph. This allows you to get new navigation data each month. So we have all the latest waypoints, sits and stars, etc. It's very nice to have, so we don't have to worry about missing any data. So you can consider that if you want to. Here on this page we also have a drag and fuel flow factor. Now I'm not sure to what degree this is simulated in the PMDG 777, but this allows you, by clicking ARM or typing ARM in the scratchpad and putting that here, it allows you to adjust the fuel flow factor of the airplane. So over time, as an airplane gets older, increased wear and tear, also depending on the position of the center of gravity, the airplane will burn a little bit more fuel, and then you would be able to, for example, adjust the fuel flow right here. Now I'm just going to leave it on 0.0 for now, but this is more of an airline thing. If you want, you can maybe, if it's simulated, I'm not sure, then you can play around with this in conjunction with SimBrief to get the most accurate fuel flow factor for your airplane as you fly your long hauls. So I'm just going to leave it at 0, and then we're going to go to the position initialization page. And again, we are aligning the ADIRU, so we're going to also have to give it a position. The GPS position, as you can see, it asks for a set inertial position. The GPS position is usually the most accurate, so we're just going to put that in right here. However, these days with GPS jamming, it is a bit tricky. You do have to check that the GPS position corresponds with the other positions. The way you can do that is also by typing in the airport code right here and the gate where you are parked, Echo 19er, and as you can see, it pretty much closely corresponds to the current GPS position. Also make sure that the UTC time is correct, and on the other pages you can make sure, you can see some of the other positions that are being used by the flight management system. Okay, so we've now given the ADIRU position to align itself, so it will continue to do that in the background, and we can go to the route page. So on the route page we can request a route. Now the most common way, especially for the long haul flights like this, is to request a route through ACARS, and it's all simulated on the PMDG 777, so if you've created a flight plan using SimBrief, you can use the SimBrief downloader, which will place the flight plan in a certain folder, and then you can request that flight plan through here. So we're going to click request, and as you can see, a flight plan is stored here from Amsterdam to Los Angeles. So we're going to load that by clicking select. There we go. Give it some time. It's going to request it right now. And of course, in real life, this would be uplinked to the airplane. In this case, it's kind of simulated here to simulate that uplink. But it's just going to load the flight plan that we've created with all the waypoints into the system. So as you can see, it gives you some options. You can either purge it or load it. In the scratch pad, you can see that some other uplinks are also come with it. We're going to clear these messages for now. There we go. And then we're going to click load. And this is going to load the flight plan into the system. Give it some time. It usually takes some time. So as you can see, the route has now been uploaded. I did find that it does not always completely correctly do it, but we're going to enter a runway and then also enter our flight number right here, or call sign. This is what ATIS also sees. Runway 24 is active today, so I'm already entering it. So I'm going to activate that and execute. Now this FMS also has a route 2 function, and if you hit route copy, it's going to copy the whole route that you've just loaded into the route 2 page. And it's kind of nice to have. So as you can see here on the legs page, route 2 legs, all the legs are in here as well, all the waypoints, and it's nice to have that as a backup. If you make any mistake in the route 1 page, you can easily switch to the route 2, and then you have the whole flight plan as a backup. Okay. So that's all in there. We've activated and executed it, and we're just gonna load a departure as well. We know runway 24 is already active, so I'm gonna select runway 24 on the departure arrival page. Make sure it's for route 1 because that's the one we're using, and then we're gonna load the Berg to share a departure, and then we're gonna hit execute. So our route has now been loaded in for the departure, and yeah, basically the whole flight plan as well. So just going back to the route page, and then as you can see, it will follow the logical order. It now wants you to go to the performance initialization page, so let's click that. Now also, this is information that can be uplinked. However, again, I did find there are some discrepancies between what is in SimBrief, so we're gonna accept it for now, but I'm just gonna run through all the items right here. Now you do have to enter a 0 fuel weight, so this is the total weight of the plane with all the passengers on board, but without the fuel, and you can just simply find this on your flight plan. So we put that in right here, 206.6, and then with the fuel, as you can see, it will calculate what the total gross weight of the airplane is, 296.2. The reserves are also on the flight plan. Let's take a look. It's usually the final reserve fuel plus any alternate fuel for your reaching your alternate destination. So I'm just going to enter the correct value that's on the flight plan, which is 5.7. Initial cruise altitude is indeed going to be flight level 320, and we're going to be flying with a cost index of 15 today. So the cost index is kind of a value which determines how efficient your flight's going to operate. It's a ratio between the time-related cost and the fuel-related cost. So if you are behind schedule, for example, a flight plan would usually come with a higher cost index, which means you're going to be flying a little bit faster throughout the flight, which of course will cost a little bit more, but then at least you are arriving on time. If you have plenty of time, if you're ahead of schedule or on schedule, we can have a nice low cost index, which will make you fly a little bit less fast, but also save some fuel. So yeah, the flight plan will come usually with a value. You can also enter this in SimBrief, and throughout the flight, if you notice that you have been flying with a cost index of 200, for example, but if you're in the air, you notice, well, actually you're arriving quite on time, especially on long hauls. So then you can select a lower cost index to save a little bit of fuel with the expense of maybe arriving a few minutes later, but then at least you are still on time and you're saving a little bit of fuel. So it's important to kind of play around with this value in cruise time. We're going to leave the performance and the route now as it is. As we come back with some performance calculations, we're going to continue with this. We are going to check the lags page, and what you would want to do here is, of course, cross-check with your flight plan whether all the waypoints are correct. So you start with the SID chart. Let's take a quick look. So as you can see, we have the Berkeley to Sierra departure, so make sure all the waypoints are correct and any restrictions are entered. So for example, at this waypoint Alpha Mike 009er, we have to be at 2500 or above. Also make sure you check the speeds. You can enter that manually if required as well. So let's say for some reason there's, for example, a speed restriction here. You can enter it this way. There we go, and then you would have a speed restriction of 220 knots at Alpha Mike 051. So that's just a way to enter a restriction like that. Okay, so make sure you run through the flight plan. Make sure you check all the waypoints are corresponding to what is actually in your flight plan, so that you have uplinked the correct route. Also check out the waypoints of your, the coordinates of the flight plan. As this is an oceanic flight, we'll be not using just waypoint but also coordinates, and as you can see in the flight plan overview, you just have to cross-check whether those coordinates are correct, and it's also important to check these kind of coordinates that are between two latitudes. So this one is, for example, between 68 north and 67 north. Make sure they are correctly entered, these halfway latitudes. Basically you just cross-check through the flight plan and make sure that all the waypoints are in there. Now, of course, you could also type in the route manually if you want to. It takes a little bit of work. You can do that here via the route page. You can simply enter the airways and then it will automatically recognize where you go onto another airway. Or if you have a direct, you can also enter a direct. There are different ways of entering coordinates in the flight system. So I'm just gonna show you on the legs page. So for example, let's take a random point, 72 north, and then west. Let's take a look. 060 would be entered like this, for example. You can look up in the documentation of other ways of entering such coordinates, but just to show you how to enter a coordinate like this, or you just type it out fully like this. So we're just going to erase that for now. One more thing we want to do is upload some wind data. We'll take a look here on the other CDU on the progress page. This is quite important because you want to have the latest winds, especially as we're going to have some headwind, of course, flying into the west direction. Load up the winds once the fuel are loaded, which in our case it's already done, so that the FMS can make the accurate calculations. So we're going to load the wind data. It already came in with the initial uplink, otherwise you can request it again, and we're going to hit execute. So I think in the background it already made some calculations, but in real life you would of course see that you either burn a lot more fuel than without winds, or if you're flying eastbound you would burn a lot less fuel. Okay, so especially for these long hauls it's very important to request the wind data, and also to do that during the cruise a couple of times as the wind data gets updated. Okay. So that's all set. We're going to take a look at the VNAV pages, make sure all the information is here correct. So for example, for the climb phase you can see what the speeds are. If you're flying from a high altitude airport, you can, for example, if that airport is at 5,000 feet above sea level, you can, for example, change the speed transition where you go from 250 knots to a higher speed to a higher altitude. You can do that right here. Transition altitude can change depending on where you're flying, depending on your airport, so where you switch from the local QNH to the standard QNH, things like that. You can check the cruise page as well, see what your econ speed is, and the descent page we're not going to use right now. We're going to use that in flight. So that's it for now. We'll take a look a little bit later at the FMS, but that's the initial FMS setup complete. We've loaded all the routes and the wind data, and we'll come back to this CDU once we are making some performance calculations. So now that some of the initial setup of the CDU is done, we can go through the pre-flight procedure. Now this is kind of divided between flows between the first officer and the captain. But of course we're single pilots, so we're going to have to do it all ourselves. But here you can kind of see what the flows are as we pass the different panels. And you will see that it will follow quite a logical order. And also the overhead panel is kind of organized in quite a logical order with some nice schematics that we can use to check out the different systems and make sure all the switches are in the positions that we want them to be. Okay, so we're just going to take it step by step, and we're going to start with the first officer flow by going to the overhead panel. So the way I will go through this is by simply just showing you what the positions of all the switches should be, and then after that I will also explain a little bit per system what it all does. Okay, so we're going to treat the overhead panel column by column. We're going to work up and down like this, and then we're going to go through the rest of the flight deck. So we'll start up here. Here we have the broadband system switch. It's a guarded switch. A guarded switch usually means that it has to be closed. And by closing a guarded switch, it will move the corresponding switch to its normal position. This is for internet on board the airplane, so we'll just leave it closed and it will turn on like this. Then the ADIRU, already talked a little bit about that. Make sure it's on, that the off light is extinguished, and that the on battery light is extinguished. And yeah, like I said, it will align the aircraft's position to true north, provide attitude information and other information to various systems on board the airplane. And as you can see, in the meantime, it is already aligned, showing the displays and the attitudes on the PFD, and allowing us to check our navigation display. So that is all in order. Thrust asymmetry compensation. Make sure the switch is on auto and that the off light is extinguished, and make sure that the primary flight computers, again guarded switches, is set to auto, and verify that the disconnect light is extinguished as well. Now the thrust asymmetry compensation is a very important system on the 777. It allows the aircraft to add rudder in case of a yawing moment, in case of a difference in thrust between the engines. Okay, so in an engine failure scenario, thrust asymmetry compensation automatically applies rudder input to help you fly the airplane. So leave the system in auto. It's very important to have, and the primary flight computers, every control input basically that you give on the yoke runs through the primary flight computers. Also enables use of things like the autopilot, auto speed brakes, etc. It's the core system of the electronic flight control system, or the fly-by-wire system on board of the airplane. So only in non-normal situations you would deal with these switches. So leave it all on auto, and just make sure that everything works accordingly. Then we move over to the electrical panel. Make sure that battery switch is on, and that the off light is extinguished. Same for the in-flight entertainment, passenger seats and cabin utility switches on with the off light extinguished. The APU, you can start already if you want, but we're going to do that a little bit later, depending kind of on the situation. If it's very hot outside and you need some cooling air, you can start the APU. If you have ground area, you would not really need that. In this case, the temperatures are not that bad, so we'll just leave it off for now. The APU generator switch is on, and verify that the off lights are extinguished. The bus tie switches are in auto, with the isolation lights extinguished. The external power switches are on. We already turned them on with the electrical power up of the airplane. Then the generator control switches have to be on, and the off lights will be illuminated. And the backup generators are on with the off lights illuminated, and the drive switches, well, again, guarded switches, don't touch them. The drive lights should be illuminated. So let's take a quick look at this panel. APU I kind of already explained. These switches are for power to the passenger seats and cabin utility systems. It's usually left on only in non-normal situations. If you are, depending on a lot of power on the airplane, you could switch some of this off. The bus tie switches make sure that all the buses, the main buses where a lot of systems of the airplane are connected to, remain powered at all times. So, for example, there's an engine failure. It would be able to close a bus tie to make sure that the other generator powers that bus. So if you want to have a bit more detailed view, we can go to the display select panel here, and it's very nice to, as you learn the airplane, to view these schematics. You can see what the system is doing. So for example, the secondary external power is now supplying power to the left main bus, AC power. Once we start the APU, we will see that the APU will take over from the secondary external power, and the primary external power is powering the right main bus. So a little bit of background information there. It's very nice to see. You can see how the bus tie switches operate, but the airplane is smart. It will handle all this automatically, so just leave it in auto. The generator control switches connect basically the generator of the airplane, of the engines, to the buses. As we start the engines, you will see that all these off lights and drive lights will extinguish, indicating that the engines take over the electrical power of the system automatically. So the engines also come up with a backup generator, as you can see. And the drive switches, again, don't touch them. It's just a system of disconnecting, if necessary, the drive, the integrated drive generator, the generator of the engine, from the engine itself. And this, if you would disconnect it here, and then it would require a maintenance crew to reconnect it again. So it's only used in non-normal situations. So just leave it as it is. Next up, we got the camera light switch. You can turn it on if you're using the camera system at night. However, the camera system isn't operative. It would allow you to make it visible over here, and in night conditions it would illuminate the gears to see where you're going, basically. But since it's not simulated on the PMDG 777, we might as well leave it off. The wiper switches, off. If you have some rain, of course you can use that, but we don't have any rain right now, luckily. Now the voice recorder switch, we already put that on. It will switch to auto as we move the fuel control switch to run on the first engine start. Then right here we have some switches. The emergency lights make sure that the guard is closed and that the switch will go in armed. Service interphone is off. Passenger oxygen switch, again a switch with a guard, so make sure it's closed. And the window heat, make sure they are all on and that the in-op lights are extinguished. Now emergency lights, these are the lights, in case of an electrical power loss. There are still some batteries that power the emergency lights, in case of an emergency evacuation, for example. So you can actually see where you're going, and they have to be in the armed position. The service interphone is kind of an interphone system that connects various parts of the airplane in case of maintenance. Maintenance personnel throughout the airplane can talk to each other through this system. So it's only a kind of a maintenance thing. It's not used in flight. Actually, if you leave it on, it would create quite a bit of static noise on the intercom system. So best to leave that off. Passenger oxygen switch, only used in non-normal situations. It would release the cabin passenger oxygen masks in case of decompression, so you do not want to touch that. And the window heat, it just makes sure that the windows are electrically heated, and anti-fogging also capabilities for the windows. And by heating the windows, it allows you to see forward and outside, but it also makes the windows a little bit stronger against any impact from, for example, birds. Then we move over to the next panel, the hydraulic panel. The ram air turbine switch, make sure the guard is closed and that all the lights are extinguished. Then we have the primary hydraulic pumps, make sure that the left and right engine primary pumps are on. The fault light will be illuminated. Make sure that the C1 and C2 electric primary pump switches are off. Fault lights are illuminated. Then we have here the row of demand pumps. Make sure that they are all off and that the fault lights are illuminated. Now, the ram air turbine is, as you may know, a little propeller that comes out of the belly of the airplane in case of an, for example, dual engine failure or some other scenarios. It provides some backup electrical and hydraulic power to the airplane if necessary. Again, a guarded switch. We're not going to use that. It would require maintenance personnel to restow it. So it's only used in non-normal situations. Then the hydraulic panel, as you can see, we have primary pumps and demand pumps. And they are driven by various sources. So for example, there are engine driven pumps, electrically driven pumps, and then the demand pumps are also electrically driven or air driven. So we're going to touch these switches later on, just before startup, and you will notice that all the fault lights will be extinguished while they're illuminated right now. And once we start the engine, you will see that the engine will take over the hydraulic power on these primary pumps. Okay. Now, basically said, the primary pumps, just like they the name says, are the primary sources of hydraulic power of the flight control system. The demand pumps work when the system logic anticipates high demand, or when any of the primary pumps pressure is low. Okay, so it kind of serves as a backup as well. So again, this is all automatically handled. We'll put these switches in the right position just before startup. Then we have the seatbelt sign. Make sure it's off for now. We're going to turn it on to auto or on as we start our engines and start our pushback. Then we have some light switches here. In general, it's nice for light switches to leave them in the mid position, maybe except for the panel flood lights, things like that, which allows you to adjust the lights, without having them too dim or too bright in any scenario. We have some dome lights here that you can of course also use, and some storm lights would be used, for example, well, if there's a storm and you want to prevent any brightness from affecting your eyes too much, you can use it. What's nice about the 777, it has a nice master brightness switch, and if you push this switch in, it will control the brightness of the various lights in the flight deck and of the displays automatically all at once. So it's kind of nice to have. Just leave it in the mid position, and then you can adjust all the lights at once in the flight deck. Landing lights, of course, we want to make sure that they're off, because we do not want to blind any of the ground personnel. Then over to the next column. Here we have the APU fire panel. Verify that the APU bottle discharge light is extinguished and that the APU fire switch is pushed in, and that any warning lights are extinguished. The cargo fire panel also verify that the arm switches are off and that any fire warning lights on them are extinguished. And here we have the discharge switch. Verify that the cargo fire discharge switch is extinguished, and again, a guarded switch, so we just leave that closed. Now APU fire, in case there's an APU fire, you can, through this handle, deal with that situation. You can discharge a bottle in the APU to put the fire out. The cargo fire suppression system on the 777 is quite extensive. I won't go into too much detail, but especially for ETOP certification, it's very important to have a good cargo fire suppression system. So, just leave these switches as they are. It's only used for non-normal situations. Then we have the engine panel. Here we have the EEC mode switches. Make sure they are in normal. Again, a guarded switch, so just leave the guards closed. The engine start switches, make sure they are in normal for now, and then the auto start switch has to be in on with the off light extinguished. Now, the engine can operate in different modes, in normal or alternate modes. In some non-normal situations, you would it would switch automatically, or you would switch yourself to another engine mode. But again, it's more of a non-normal situation thing, so we'll just leave the switches as they are. The engine start switches, we move to start as we start the engine, and the 777 comes with an auto start system, so it will kind of monitor the engine start and control the engine start itself, and will automatically abort it in certain conditions. So it's nice to have that on, and during the startup process of the engine itself, we'll take a little bit look at how it does. In the fuel jettison panel, make sure that the nozzle switches are off and that the valve lights are extinguished. Again, guarded switches, so don't touch them. The fuel to remain selector has to be in, so like this. And make sure that the fuel jettison arm switch is off and that the fault light is extinguished. Now, fuel jettison, again, of course, a non-normal condition panel that you would use for fuel dumping if necessary. Then we got the fuel panel. Make sure that the crossfeed switches are off and that the valve lights are extinguished. And then the fuel pump switches should all be off. You will see that the left forward pump pressure light will be extinguished once we start the APU. This is normal system logic. The APU will automatically turn this pump on, but we have not powered the APU right now, so the pressure lights on the left and right pumps will be illuminated. And on the center pumps, they are actually extinguished, and that's quite normal because the center pumps, the center tank do not have to contain fuel. in every scenario. If you have a short flight, there would not be any fuel in those tanks, so the pumps can be left off, and then therefore they will not show a pressure light. Okay, so this is all normal. The crossfeed switches would be used if you have a fuel imbalance. If the aircraft comes up with an ICAS message regarding fuel imbalance, you can use the crossfeed system to let the airplane or let the engines take fuel from one side of the airplane, so from the right fuel tanks or from the left fuel tanks. Again, this is more used in a non-normal condition. In normal situations, the crossfeed switches are left off like this. Then the anti-ice panel, make sure that the wing anti-ice selector is in auto, and same for the engine anti-ice selector in auto. We'll take a look a little bit later after startup on how to deal with this system. Then the lighting panel, make sure that the beacon is off for now. This would only be used just before startup, and then the other lights as needed. It's nice to kind of have navigation lights on if the airplane is powered, and at night, of course, if you want to make sure that your airline gets seen, it's nice to turn on the local lights as well. The wing lights are not really used, usually mostly for inspection. The indicator lights, you can test all the lights in the flight deck to see if it's all working. And you can also put it to dim or bright depending on whether you are flying at night or in daylight respectively. When the turn off lights and taxi lights and strobe lights are all left off for now. Next up we have the air conditioning panel. Make sure that the equipment cooling switch is in auto and that the override lights are extinguished. The Gasper fans are on. The recirculation fans you can turn on, but there is a little bit of a but. I will explain that a little bit later. You can leave the flight deck temperature control in the mid position, in the auto position. Same for the cabin temperature control. The air conditioning reset button you don't have to touch. We can switch the PACs to auto, and we leave the trim air switches to on. Verify that the off lights are extinguished if you're using the APU already. In this case we're not having don't have an external bleed source yet, so the off lights are still illuminated. And on the trim switches, make sure that the false lights are extinguished. Then the bleed air isolation switches, make sure the left, center and right isolation switches are all in auto and that the closed lights are extinguished. And then here we have the engine bleed switches, make sure they are on. The off light will stay illuminated until a engine is started. And the APU bleed switch also to auto, and verify that the off light is extinguished. Now, so this is the whole air conditioning panel. The reason why I said there's a but is if you're using ground air, you want to be a bit careful with this. If a ground air card is connected, which you can do through the FS Actions menu on the PMDG 777, you want to make sure that you leave the recirculation fans and the PACs off while that is operating, because it might damage the PAC system if you operate them both at the same time, or it might just not allow the ground air cards to operate efficiently. So make sure they are the circulation fans and the PACs are off if you're using that, and then after you verified with the ground crew that the ground air has been disconnected, you can turn on the recirculation fans and the PACs in the flight deck. So the rest of this panel again is very nice through the display select panel to view the synoptic of the system. Right here you can kind of see how it operates and through the different phases of flight. So as you study this airplane, it's very nice to keep these kind of pages open. You can see, for example, the flight deck temperature. The target temperature is 24 degrees, but it's currently 16 degrees in this area. So the magenta is the target and the white is the current temperature. As we do not have any bleed sources yet, no APU or engine started, it will not warm up yet. So if it's a very hot day or a very cold day, you would start the APU early or use the ground air system. Okay. So just to give a bit of a review of all the switches here, the equipment cooling switch, they provide cooling and ventilation for various electrical components and equipment in the flight deck and other parts of the airplane. Quite important because a lot of systems and displays get very hot on the airplane, so it's important to have good cooling. The Gasper switch is for the little air vents above your head in the cabin, the passenger seats. Recirculation fans, they, as the name kind of says, recirculate air. They help with cabin ventilation by reducing the flow required produced from the packs. So it just takes in some cabin air, pushes it through some filters, and then reintroduces that air. And by reintroducing some air, you can save some fuel by not having the packs push in fresh air the whole time. Flight deck temperature, you can leave it auto. You can make it colder or warmer as desired. Cabin temperature, same kind of thing. If you leave it in the mid position, you give full controllability on the cabin attendant control panels. They can adjust the temperature in the different zones of the airplane themselves. So as you can see, there are different zones on the airplanes, and if you just leave this switch in the middle, they have full range controllability of the temperature. So it's best to leave this in auto or in the middle position, sorry. Then we have the PACs. The PAC switches, again, most of this is all operated in auto. Only in non-normal situations would you push a switch out of the auto position in this system. The PACs receive hot bleed air from the engine or the APU and cool down that air before passing it through the air manifolds. It's very important to have the PACs operating, of course. The trim air switches, what they do is, the trim air valves on board of the airplane can mix hot bleed air with cool air from the air conditioning PACs, allowing you to control the different temperatures in the different zones more precisely. If you would turn this off, it would kind of set a global target temperature, but by having the trim air systems on, it allows for more precise adjustments in each zone. So for example, if you would adjust the flight deck temperature, it will actually manually control one of the trim air valves to the flight deck to set a certain temperature. Now the bleed air isolation switches, again, leave it on auto. It is, you can see also the schematic drawn on the overhead panel itself, and again also here on the synoptic display. You can see that they're all closed right now, but as you start the APU and the engines, it will reconfigure itself, open the isolation valves up. In any non-normal situations, when there's a duct leak or an overheat of a certain duct, the system will reconfigure itself in the background to detect the leak and also make sure it doesn't, that the system is configured properly for that leak. So there's a lot of system logic behind here in the system that will operate automatically in any situation. The bleed air switches, basically the valves will open when bleed air is available from these sources. So the engines provide bleed air for this entire system. So that's air coming off the engine, or the APU can also provide the bleed air. So we'll just leave these switches as they are. As we start the engines, you will see that the off lights get extinguished and supply bleed air to the PACs, and it will all configure automatically. Then we have the pressurization panel. Make sure that the outflow valve switches are in auto and that the manual lights are extinguished, and push the landing altitude selector in. And here you have some switches to manually manipulate the outflow valve. Now the outflow valves control the cabin pressurization by letting a certain amount of air out of the cabin. That's very normal to have them open a little bit. Depending on the stage of flight and whether you've landed, for example, upon landing they will fully open to depressurize the cabin. Let the system all handle that automatically. Again, in a non-normal situation you would have to use manual outflow valve handling. You can do that through these switches. The landing altitude, push that in. If you've loaded a flight plan and a destination airport, it will automatically determine the landing altitude, okay? And based on that, it can regulate the pressure during the cruise and during the descent, for example. And lastly, on the overhead panel, here we have the wiper switch. Again, it's not raining, so we'll just leave that off. Okay, then we continue with the flow of the first officer. You know, if you're flying a single pilot, it's not super necessary to go through all this, but it's kind of nice to have the airplane configured properly, of course, even if you're flying this airplane solo. The flight director switch is going to be turned on, and here we have the display select panel. If you press the lower center button right here, display switch, you can view the different synoptics as I just showed you on the different pages. Okay, you can also do that for the right inboard display or the left inboard display, but for now we'll just leave it on the lower center. Okay, so you can kind of play around with that. Also, you can view checklist and communication pages, things like that. We'll take a look a little bit later. And here we have the EFIS. You can just make sure that you set everything. Minimums is not really required. Some people like to put a certain reminder. If you have a certain takeoff procedure, you can set a certain altitude reminder here. But we're just going to reset it now. You can turn on the flight path vector right here on the primary flight display, and if you're flying in areas of the world where they use meters, you can turn it on here. You can set the QNH. QNH at the moment at Amsterdam is 1008, so we'll just set that right here. There we go. You can turn on the VOR left and right indications, showing you what kind of VOR is tuned by the 777. 777, all the tunes, all the radios. You can tune it manually if you want through the navigation radio on the CDU, but in principle the aircraft will, let me just cancel that, will auto-tune VORs and ILSs as you select approaches. Okay, so that is nice to view what it has tuned here. If you're using ADF, you can also of course use an ADF for that. Okay, then here we can view the map or a plan. It's nice as you as we just did. If you skip through the legs page, you can click on the legs page in the plan view and then step through the different waypoints of your flight plan. It's very nice, especially for departure and arrival procedures, to make sure that everything is correctly set. And then with the range switch, you can adjust the range of the navigation display as you scroll through the flight plan. If we go back to map, as you can see, the step function disappears. We're just viewing the normal map view. You can also press center. It gives you a more centralized view with the whole compass rose around you. And on the 737 you may have a vertical situation display. This airplane doesn't have that, so pressing center again will just return you to the normal map display as it is here. And here we have some other functions. You can turn on the weather radar. Do not fry the personnel on the ground yet. You can do that once you start taxiing, so we'll leave it off for now. But you can view some other information like VOR stations in the area, waypoints in the area. Airports is nice to have always turned on. Same for traffic, make sure that it's turned on. For now TCAS is off, but once we line up on the runway, we're going to turn TCAS on. It's of course very important to have data. If you want to see some additional data at various waypoints, like the estimated time of arrival over at the waypoints, you can view that. You can view the different positions calculated by the airplane. And of course we also have a terrain display, which is very nice to have if you are flying in high terrain areas. Then we come back over here. Of course the window can also be opened to make sure it's closed. We have here another oxygen mask. Make sure you give that a little test if not done already during the preliminary pre-flight. Make sure it's on 100% and the doors are closed. Here we have some light switches, use them as desired. Of course we come across the EFB here in the flow as well. Just make sure that you for simming purposes have entered your sim brief ID and stuff. You can do some ground operations as well. We'll take a look a little bit later here as we're going to use that. And here we have some more brightness and light switches and floodlights. Again, just leave them in the mid position so you can adjust them accordingly later on as it gets dark. Some heaters, if you're cold, you can of course heat your feet and shoulders a little bit. Here we have some instrument source select switches, navigation source select, display control source switch, and air data attitude switch. Just leave them all off. We barely touch this. You know, the airplane reconfigures a lot of stuff automatically, but in case of failures of certain systems, and you can use alternate modes as to what the display is used to draw information on the display, or how it displays attitude information and stuff like that. I will not go into much detail for these switches, but just make sure that they're off as they are right now. Next, you might have a clock here. Make sure you reset it and make sure it's set to UTC time. In this case, we have a digital clock on this airplane, so we do not have to touch that. Next we have the inboard display selector. It's nice to have that on MFD, multifunction display, so we can use this display for other functions as well. So you can select right inboard here and view, for example, the doors, the status of the doors, things like that. A nice little trick to just simply get it back to the navigation displays, to switch to nav and then back to MFD. It will default to the navigation display right here. You can use the switch to also view other information on this display in case of failures, for example. Then you can use this switch accordingly, but leave it on MFD for now. Then we have the FMC source switch. Again, leave it on auto. The airplane handles this automatically. The airplane has two FMCs, flight management computers, that make calculations for the flight management system. The airplane uses the left FMC by default, and the right FMC will monitor. If anything happens, it will switch, but if you need to manually switch, you can do that through this switch, but we can just leave it on auto. Then we come back to the displays, and it's important to kind of check the displays just to make sure that all the information is correct, so that the flight instrument indications are correct. No altimeter is really off. You should have some indications, no V-speeds and TCAS off. That's normal at this stage because we haven't calculated any V-speeds or put in any V-speeds yet, and the TCAS system is still off, so that's normal. Make sure there are no flags, any other flags in there that would indicate an anomaly with the system. At this stage, the auto throttle mode is indicated right here on the PFD. It should be blank. And the roll mode is indicated in the middle. It should be toga, and the pitch mode is also toga. This is a normal indication for this stage. And since we turn on the flight director, it should also indicate flight director right here on the autopilot flight director system. So these are all normal indications. That's all correct. Then we come over to the landing gear panel. Here we have some switches that would be used, for example, in non-normal situations when you would land with a flap setting that's different from normal. You can override the system, but we just leave all these switches off. So the ground proximity light has to be extinguished. You can leave the flap override switch off, the gear override switch off, and the terrain override switch off. Make sure that the landing gear lever is down and that the alternate gear extension switch guard is closed. Again, a guarded switch, so we're not going to touch that. And we can move the auto brakes to RTO already, which I believe on the 737 is not possible, but you can on the triple already do that at this stage. Okay, so alternate gear extension, in case of an hydraulic failure of some sort, you can use the alternate gear extension system to get the gear down using its own gravity. But again, all guarded switches, and usually you'll be guided by non-normal checklists if you need to use any of these switches. Then the ICAS display, as already said, an important part of the 777. It stands for Engine Indicating and Crew Alerting System. Gives you all the warnings associated with the airplane, or advisories, cautions, things like that. So make sure that you just give it a little check again. You can recall, as I said before, anything that is in there at the moment. These are normal indications for this stage, so we're just going to cancel them. But you can see, just verify that the primary engine indications are showing the existing conditions, which is correct, and there are no other exceedances shown. Not here on the secondary engine indications either. They're all normal indications, so that's all good. It's also good to check the status display again. You would go through that again as you pass it through the flow, but we already did that during the preliminary pre-flight as well. But any status messages that pop up would pop up here. We had TCAS before, but as you can see, that has now been removed, which is correct. So another thing you would do here, as you pass your display, your multifunction display in your flow, you would hit the checklist button, and it's good to go to the resets page and then make sure that you have the correct checklist. In this case, we have a rather old revision. I don't think PMDG will really upload any other checklists, but you would check if you have the current checklist that should be used at the moment. And we're going to click reset all. This just resets all the checklists, so we can go back to a normal state at the start of the flight. Okay. Also, we have, of course, the communication display. In real life, you would make sure that all the correct information regarding the registration of the aircraft has been entered. What you can do here is also, if you're going to fly on VATSIM, make sure that you have your hobby ACARS code inserted into the system. There's some information about that in the manuals on the PMDG 777 website on how to do that, but it would allow you to make use of the CPDLC and communication system here on board the airplane. So make sure that you do that. For now, this is all okay. Display control source switch, make sure it's off. Again, there's an alternate switch, alternate system available if necessary, but we're just going to leave it as it is. And here we have some more brightness control switches. We're just going to leave them in the middle position. So as you can see, quite a lot of work for the first officer, but in real life you would go, of course, through this quite fast. You will recognize quite easily when a switch is not in the correct position. But I do like to explain a little bit more detail here and there. Now we'll go through the pedestal right here. You can set the left tuning panel. I'm not gonna go into much detail, but again, if you're flying on VATSIM, make sure that you have your microphone selected to the correct VHF radio, in this case VHF left, and the corresponding volume knob is on as well. So this is to receive. If the microphone is selected, it should receive also automatically. You cannot control the volume, unfortunately, but in real life you would of course be able to. So make sure you give that a good review. The weather radar panel, we do not really touch that at this stage. You can touch that in flight. Then we have the radio panel over here. Make sure data is tuned on this one and verify that any off light is extinguished. This is the observer radio panel. It will be used for anyone who's sitting in one of the observer seats. And as you can see, there's also an observer audio switch right here. If one of the audio control panels would fail, you can use the observer audio panel, and then you would, for example, if the first officer side has failed, you can switch the observer audio to this panel, so it would use those radios. Okay, again, something you would use in non-normal situations. Then we go up here. Here we have the engine fire panel. Verify that the engine bottle 1 and engine bottle 2 discharge lights are extinguished. If any of those bottles, which is used for fire extinguishing, has a low pressure, it would be indicated here. It would require maintenance to refill that, of course. Make sure that the engine fire switches are in and that the fire warning lights are extinguished. Again, something used in non-normal scenarios. Here we have the center CDU. It's kind of nice to have the cabin interphone on here, so you can call any door as required. Okay, rudder, aileron trim, all that stuff. We'll take a look at that a little bit later. Then the first officer radio tuning panel. Adjust to your liking. You can of course enter frequencies. You can also control an auto radio, so we would now be controlling the captain's radio, and as you can see, it would indicate with this light that you are tuning a radio that is not normally tuned by this side. So it's just a little reminder. For now, we're just going to leave it in VHF right, so we're going to tune our own radio, but again, just make sure you turn on the associated volume knobs and microphone selection if needed. Then we have here the transponder panel. At this stage, the transponder should be set on standby, and as we get our ATC clearance, we'll get the transponder code. All the other switches are just used in flight and for TCAS purposes and stuff like that, so I will not discuss that now, but you can just leave these switches as they are. And here we have the evacuation command panel. Make sure that the guard is closed, and it would be used in case of evacuation. You can use the system to provide the signal. Then we have some more light switches here. We have the floor lights and the IO panel floodlights and the lights of the IO panel itself. Again, just leave them in the mid position and you are good to go. Okay, so we've now gone through the whole pre-flight flow of the first officer. Again, it takes some time, especially as you get to know the airplane, but in real life you would go through this quite a bit faster, of course. Now we're going to go through the captain's pre-flight flow. Mostly it's going to be quite similar. You're going to set up your EVIS panel. So we're going to make sure that the barrows are set 1008. That's correct. Let's turn on the flight path vector. Let's turn on some traffic for later, airport and data. There we go, that's all turned on. So just move all these switches as needed, but probably one of the more important things is to set the correct QNH in the sim. You can of course choose an option to sync all of them, but in real life you would have to do that for each pilot manually. Okay. Again, make sure that the weather radar is off at this stage. Then we go to the mode control panel. This is used to control all the autopilot functions on board the airplane. Make sure that you turn the flight director on the captain's side as well. Make sure that the auto throttle arm switches are put to arm. Make sure that the autopilot disengage bar is up, and then you can use the heading and track or vertical speed flight path angle switches as desired. Yeah, if you are planning to fly a certain track, you can already pre-select track, things like that, but we'll just leave it in heading mode for now. You can set the bank limit selector. If you leave it on auto, the airplane will limit its bank accordingly, according to the phase of flight automatically, so we'll leave it as this. And the altitude increment selector is this switch over here. Let's see if we can push it. It allows you to increase the altitude in steps of thousands or in auto. It kind of depends on the situation. You can just play around with this. At this stage it's also nice to enter some of the initial data. We'll leave the speed at 200, which is a nice reminder that we still have to enter some V speeds here. But we can already set the runway heading for our departure from runway 24 today, which is going to be 236. There we go. And then the altitude, initial climb altitude for today's departure, in this case, it's nice to set it to 1000. Is flight level 60, so that's already preset here. Then we go back again here to the bottom. Make sure the window is closed. Again, oxygen chest, if not done already, make sure it's 100%. Check your EFB. Make sure all the brightness switches are again in the mid position. Adjust the heating to your liking. Check the display source switches. Make sure they are all off. Then we have, of course, again the flight instruments. Again, make sure all the indications are as expected. No V speeds and TCAS off flags are normal at this stage. The inboard display selector is again used while we can put it on multifunction display, and here we have the heading reference switch. Make sure it's put to normal. If you want to switch to true heading, you can do that in certain operations, but we just leave it on normal right here. So let's see what else. Well, Toga flight director is displayed. We have the flight directors on. That's all correct. So that's all good to go. Then right here, we come down here. We have the integrated standby flight display. So this is standby source of attitude and speed and altitude information, heading information. I'm just gonna set the QNH on here as well. You can adjust the brightness. You can select an approach mode. We'll just leave it off for now. We don't need it. There are no flags shown on this display either, so that's all correct. Then we come down here through the throttle quadrants. Here we have the alternate pitch trim levers, not really used, only in non-normal situations, so we just leave them in the neutral position. Then we have the speed brake lever. Make sure it's down. If you're using hardware, in your flight sim like the Honeycomb Bravo or something, make sure just give them a little wiggle. It's nice to make sure that speed brake is in the down position. Make sure that the reverse thrust levers are down. Make sure that the forward thrust levers, the thrust levers themselves, are closed, and then the flaps should be set according to the current position, which is in up. So that's all good to go. Then let's also set the parking brake. That's a bit tricky on the 777. I also read some forum post topics about it. What you want to do is, I've set the realistic option in the simulation options. Just press the brakes, and then we're going to pull the parking brake switch. I've set a button also on my Honeycomb Bravo throttle quadrant, and then it should set the parking brake. It might take a little while to catch on, but if the parking brake set message shows on the ATIS display, which it does right now, the parking brake is correctly set. So again, this is your friend. It shows you the correct status of the parking brake. So it is correctly set right now. In some situations your brake accumulator might be a little bit low. In that case you would have to contact ground personnel to ask if the bypass pin is inserted, and then you can pressurize some of the hydraulics to build up some pressure, but in this case the parking brake is correctly set. Then let's get back in the flow. We went this way and we set the parking brake. Here we have the stabilizer cutout switches. Again, guarded switches, make sure they are closed. If there's a non-normal situation with the stabilizer, you could use these switches to cut out the stabilizer system. Again, you would be guided by a non-normal checklist if that's the case. Fuel control switches, make sure they're set to cut off and that any fire warning lights on them are extinguished. This is used to introduce fuel as we start the engine. We'll also see momentarily. Then we'll check here on the right. We have the alternate flaps panel. Make sure that the alternate flaps arm switch is off. Again, a guarded switch, so make sure it's closed and make sure that the alternate flap selector is off. And then you can, of course, adjust your own audio panel on your side as needed. So yeah, that kind of completes the pre-flight flow for both the first officer and the captain. As you can see, it takes a little while, but as you get used to the airplane, you will be able to go through it quite fast. In this stage, you would also maybe adjust your seat and your rudder pedals to get a nice seating position. So make sure you also do that in the sim. Make sure you have a nice seating position for yourself for your flight. So now that the pre-flight procedure is completed, we can also do the pre-flight checklist, and this is to make sure we have done everything correctly. So we can press the checklist button here on the display select panel and it will show the checklist right here. It will sequence the correct normal checklist that is next in sequence accordingly. So we'll do the pre-flight checklist. The oxygen is tested 100%. Again, these are the oxygen masks that we've tested before and they are set to 100%. Then we have the flight instruments. Make sure we give a good view of all the heading and altitude information on the different displays. So we have a heading of 121 here on the standby display as well, on the first officer side as well. Make sure you also take the compass with that. It should correspond sort of to your current heading. So that's all correct. And altimeter is 1008. Probably have to update that a little bit because it's not completely showing the correct altitude for this airport. But make sure they're at least the same at this stage. So 60 feet here, and here on the first officer side as well. So that completes the pre-flight checklist. And as you can see, some of these items are already automatically ticked off by the system, by system logic. So if you have the parking brake set and the fuel control switch to cut off, you do not have to tick them off in this way. Okay, so that completes the pre-flight checklist, and we can close the checklist by clicking the checklist button. Now at this stage, of course, the passengers might be boarding and the cargo is still loading, so the doors are still open, things like that. So it's a nice moment to kind of take a look at your performance calculations and maybe also get a clearance as well. So we do already have a certain expectation for which runway we're going to use. So but first, let's click the communication page, and now, which is really nice here on the PMDG 777, nicely simulated, we can, of course, there we go, request a ATIS. So we're going to click on flight information, and then we're going to click on ATIS requests, and you can determine which source you want to use. I do believe there's some ATIS online on VATSIM right now for Amsterdam, so we can do that. And of course, sometimes it fills it in automatically in real life if you already selected the departure airport. But we can request an ATIS, so we get the latest weather information that we can also use for our performance calculations. Okay, so from Amsterdam on VATSIM, and we'll just send that out, so we have just one ATIS. And let's see what it comes up with. There we go. So it comes up with a new message. You just heard the signal. In real life it wouldn't display probably right here. Maybe it depends a little bit on the airplane this PMDG 777 is displayed used as a reference. But anyway, we have an ATIS right here, so we're going to keep that open. In real life it's also nice to print that, so you can have it on paper. So let's take a look at the ATIS. As you can see, Schiphol information Bravo, main landing runway 27, ILS approach, main departing runway 24. Transition level is 4 or 5. If you're arriving, you can enter that in the VNAV descent page. In the forecast right here, you would be able to change the transition level right here, but that's only for arrival. We're going to be departing Amsterdam. The wind is 290 degrees at 16 knots, variable between 260 and 320 degrees, visibility 10 kilometers or more. fuel clouds, temperature 15, dew 0.8, QNH 1006. So as you can see, a new QNH. So we're gonna set that 1006. It shows a little bit more accurate altitude. 1006, and on this side as well. So make sure you set it on all sides. Noise abatement NADP2 procedure shall be applied. Acknowledge information Bravo. Okay, we're going to take a look at that a little bit later, but it's nice to have this information because now we can do some performance calculations using the EFB. So let's take a look at the EFB right here so we can do some takeoff performance calculations. And it's very important to do that properly because, yeah, of course, you're gonna take off a very heavy airplane. Sometimes in challenging conditions, you need to calculate the exact moments where you're gonna stop the takeoff, abort the takeoff. There are a lot of weight restrictions as well. I will not go in too much detail here, but having a good performance calculation really helps with achieving a safe takeoff. Okay, so I'm just gonna click the electronic flyback right here. We can request data from SimBrief. It should load up some information for our flight. And we go back to the main menu and then performance tool, and here we can import from OFB already some data. So as you can see, we already have Amsterdam Airport, Schiphol. We're going to select a runway 24 is expected. It already fills in some of the information that we're going to use. Runway condition, make sure you select an accurate runway condition. So if it's raining, if you can see a lot of rain outside, you would definitely use wet. And if in the ATIS any other information regarding the state of the runway is given, you can use one of these as well. In this case, the runway is dry, so we can just use this. Alright, then the aircraft, you can simply import from aircraft. Probably would do that this way, so you can also make sure that you have the correct weights. Flaps, we'll just leave at optimum, so it's going to calculate with what the optimum flap setting will be. The thrust rating, it depends a little bit on your configuration options. In this case, the thrust limit, thrust reduction, we only use assumed temperature on this Boeing 777. If you have a 777 that also has D rates in takeoff 1 like takeoff 2, in the thrust limit page you can use one of those as well, but we're just gonna leave it on takeoff thrust, so it only uses the assumed temperature method. Won't go into too much detail here. There are quite a few videos around probably explaining that, but we're just gonna leave it as this. Anti-ice config, if you have any expected anti-ice use, you would be able to enter that here. In this case, we're gonna leave it off. Now the weight, as you saw on the SimBrief flight plan, let's take a quick look. We have an estimated takeoff weight of 295.242 kilograms. So it's kind of nice to also add a little bit of a margin to this. So it seems that it already kind of did here, but I'm just to be a little bit precise, I'm just gonna enter a margin of 1,000 kilos on top of this estimated takeoff weight. So we're gonna be entering 296.242. And the reason for doing that is because you know, you do not have your load sheet yet. As the passengers are still loading, as cargo is still loading, you might take a little bit more weight with you than expected. So by having already calculated with 1,000 kilograms more, you kind of cater for any additional weight that might come with the airplane. So you can do that right here by having a little bit more weight than what is estimated in your flight plan. Center of gravity comes from the airplane as we imported it, and the air conditioning configuration, we just leave it on auto. If you would take off with PAX off, for example, you can enter that here. Now the weather, of course you could quickly import the weather. However, as you can see, we had main departing runway 24, and the wind is 290 degrees and 16 knots, variable between 260 and 320 degrees. And it's a good practice to kind of calculate with the worst condition scenario. So in this case, runway 24, a wind of 320 degrees would give the most crosswind and the least headwind. And of course, the more headwind, the better for the departure. So we're gonna kind of calculate with the worst scenario. So we're gonna enter a wind of 320 degrees at 16 knots. So we'll delete this. 320 degrees and there we go, 16. submit outside air temperature is let's see what it says in the ATIS 1.5, but I do believe the QNH might have changed in the meantime. It's a 1006. Okay, we'll use 1006 right here as well. 1006 hectopascal. So make sure all these fields are filled in, and now you should be able to calculate some takeoff performance. Okay. So we already have quite a few V speeds here. As you can see, it gives you a flaps 5 takeoff with an N1 percentage. We should have about 92.8 with just a regular takeoff thrust rating and an assumed temperature of 51 degrees. And it gives you a trim value and different V speeds as well for calculated for this takeoff weight. Okay, so we can already enter some of that information in here. So I'll just go back to the performance page and then go to thrust limit. As you can see, this aircraft does not have the thrust D rates takeoff 1 or takeoff 2 available, but we can enter the assumed temperature that we calculated. So let's see, assumed temperature is supposed to be 51 degrees. And what this does is kind of tricks the engine into thinking it's warmer outside than it actually is, and therefore it will reduce the thrust setting. Okay, so as you can see, it is now calculated with this assumed temperature that we should have an N1 value upon setting takeoff thrust of 93.1. Just make sure it corresponds to what is stated here, or at least that it is more than what is stated here. So that is correct. And the aircraft will also automatically set a certain climb thrust, and you can just leave it as it is. Leave it to the system itself decide what kind of climb thrust uses. If you want to use more climb thrust, you would use climb. If you want to use less climb thrust, you would climb 2. For example, in high terrain areas, you might want to opt for, if it automatically selects climb 1 or 2, you might want to opt for, just getting out of the high terrain as soon as possible and select a different climb thrust. Okay, and then we can also already enter the flaps information. Flaps 5 is what we expect for this takeoff. Also make sure to check out the second page here of the takeoff reference page by clicking next page. Here you have some important heights at which you're going to accelerate and have thrust reduction. Now it kind of depends on which noise abatement procedure is being used at the airport, and it might also differ a little bit per airline. But for an NADP2 departure, as set in the ATIS before, we can use these values. So we're going to accelerate at 800 feet, so we're going to increase the speed and retract the flaps at 800 feet, but we're also going to reduce the climb thrust at 800 feet, as you can see here. Now same for engine out acceleration height. Usually a performance tool will come up with some sort of value at which you're going to accelerate in an engine out condition. I'm just going to leave it as it is right now, but of course there might be different values also depending on the terrain, etc. If you have an NADP1 departure, which at some airports can happen, then you can of course change the value. So for example, you would then have a thrust reduction at 1500 feet above ground level, and then you would start to accelerate only at 3000 feet. So give this page also a little look, and then make sure that you have the correct acceleration and thrust reduction heights and engine out acceleration height, depending on the procedures being used at the airport you're departing from. Other than that, we're not going to enter anything yet. In real life, you would have to wait for the load sheet to enter the final information in the flight management system. So we're just going to wait a little bit for that. I'm going to go to back to the performance page, and then we'll see how that kind of works. Unfortunately, it's not possible to generate a load sheet on this airplane. Normally it would be uplinked to the aircraft. Yeah, I'll just kind of show you what it's like once you receive a load sheet, what kind of data you would enter. So we've done some initial takeoff performance calculations. If you're flying on VATSIM, it's of course also nice to get a clearance. You can do that through the communication page. Let's just remove this right now and click communication again, and then here through flight information you can get your departure clearance request. You can, as you can see, it fills in some information automatically already. So your flight number, your facility in this case would be Amsterdam, kind of depending on what is in the controller information of the VATSIM controller. You can enter the facility, departing Amsterdam to Los Angeles. Let's see, I kind of forgot what the ATIS letter was. You have to send what ATIS you have received upon sending this clearance request. So we can go to review, flight info uplinks, and then here we have the ATIS again. Okay, it was information Bravo. So we can go back to our departure clearance request. We enter information Bravo. So just putting it in the scratch pad, make sure lower center is active on this side as well. There we go. And then our gate is Echo 19er. There we go. If you have any additional requests, you can send that, put that in the free text area. So you would just send that, you will send this information to the controller. It will come back with your clearance, and this all works very nicely. Now it's not simulated here because we're not flying online on VATSIM at the moment because I'm making this tutorial. But let's say we got a clearance for runway 24, the Bergy to Sierra departure. It is what we've calculated for. It's what's already programmed in the flight management system. Let's say we got a squawk code, let's say 1624 or something. Okay, and then it usually also comes up with a frequency that you have to contact next. In this case, Schiphol Planner 121655. So I'm just gonna pre-tune that in the radios here already, so we can take a listen to that and report when we are ready for our departure. So we've got the clearance, and yeah, this is the way you would be able to send that through on VATSIM. Okay, so there we go. So again, we got the clearance. We've done some takeoff performance calculations. In the meantime, yeah, passengers might still be loading. The doors are still open probably. Of course, you can select the doors on one of the displays right here to keep an eye on things, and so we'll just have to wait a little bit. At this moment it would be nice to do a little bit of a briefing for yourself, so I'm not going to go into much detail. I'll probably do a VATSIM full flight with this airplane sometime later, so we can kind of view how that works. But it's nice to give yourself a briefing for your departure, so see how your pushback would work, how you're going to fly the departure, what are the different waypoints that you're going to pass. And also, if you want to do it very properly, of course, also discuss non-normal situations, what you would do in case of an engine failure. How would you return? Would you dump fuel, or would you do an overweight landing? Things like that. So these are all things to consider, especially because we're flying a heavy 777. In most cases, you're going to be above your maximum landing weight. So in case of return, you have to think about how you're going to deal with the situation. If it's a very urgent situation, you might do an overweight landing. If it's less urgent, you might dump some fuel, etc. So these are kind of the scenarios you are going to brief, well, in this case with yourself, but in real life, of course, with your colleague pilots. Alright, so it's slowly time to start moving. So I'm just gonna call up GSX. I'm gonna be using GSX to do the pushback on the airplane. So I'll let that prepare for pushback and departure. Let's see what kind of options it gives. Probably a default option for pushback right here, so that's okay. Now a few minutes before departure, you would also start up the APU, the auxiliary power unit. It's a little engine in the tail of the aircraft that will help provide some electrical power.
Departure checks completed. Bypass pin inserted.
That's the ground crew, and that's good to know. All the checks downstairs have been completed, and the bypass pin has been inserted. That's some important information. So we'll start the APU for some bleed air for the engine start and some electrical power as well. So move the switch to on, and then we'll start it. There we go, holding it in start for a few seconds, and then it switches back to on. So in the background, the APU is now going to start. Now, we've already talked a little bit about this in the pre-flight. As you can see, the pressure light of the left forward fuel pump has been extinguished right now, and that's because the APU is automatically enabling that fuel pump as it requires fuel to operate, of course. So that's kind of nice to see. Soon we'll see the APU running message here on the ICAS memo messages, and of course you can also take a look at, for example, the air synoptic to see what happens as the APU starts up. So let's take a look once we have some bleed air from that system. So as you can see, the APU is now running, and as you can see, the system is reconfiguring itself, very nicely displayed. You can also hear it in the background that air is now actively being pushed through the cabin, through the packs, and all the isolation valves operate automatically as we've set them during the pre-flight procedure. Same for the electrics, very nice to view that here. The APU generator is now running, and as you can see, it now takes care of the left main bus. The bus tie switch has closed, and it's now controlling that instead of secondary external power. And because the APU is running, we can also remove the ground power. Now you have to be a bit careful with this. You really have to actually remove or switch off the external power here on the overhead panel. The ground crew is already ready to do that. We have the APU running, so we can use the APU as our electrical power source. Secondary external power is already, we already disconnected it here. As you can see, it shows the available light, but the primary external power we are still using, and we have to press that button so it shows available, as you can see, so that we're now only using the APU. We're not using any of the external power, primary or secondary. And now we can tell the ground crew to actually remove the ground power, because if you don't do that and they unplug the external power when it's still connected, then there will be a lot of sparks downstairs. It's not very safe. So we're going to go to the FS Actions menu, ground connections, and then we can release the ground power at this point. In the meantime, let's also check all the doors, so we can view the doors. Well, I think the gate has already been removed, so we can close this door definitely. Let's do that right now. We'll go to the FS Actions menu and doors, and just close all the doors, so that that is all ready to go. Let's see. As you can see, all the doors are closed.
Locking gear.
Gear is being locked.
Release parking brakes.
Okay. I've let the GSX go all the way up to parking brake release, so once we release the parking brakes, we will be starting the pushback. So like I said, in real life you will now kind of receive a load sheet. All the doors are closed, so all the cargo, all the passengers are loaded. The airline knows what kind of weight is on the airplane, and it will send a load sheet with all the latest zero fuel weight, takeoff weight, center of gravities and things like that. So it's very important in real life to cross-check this. Unfortunately, we cannot really simulate it here, but at least what we can do is sort of regard the load sheet that came with the flight plan as our actual load sheet, and then actually make sure that all the weights are entered correctly. Okay, so we're going to go to init ref and then back to index and then back to performance. Here we enter the latest zero fuel weight. Now the zero fuel weight has not changed, so we just leave it as it is. And here we can check the gross weight. So here we see what our current weight is, and of course you're going to be burning a little bit of taxi fuel. So our gross weight for takeoff is going to be about 295 something. It's important to check that you cross-check with what you have calculated in the performance calculator. We've calculated with a takeoff weight of 296,242. So even if we burn some taxi fuel right now, we're well below our the weight that we've calculated for. So that's very important to note. And if you turn out to be heavier, and if it turns out that, for example, even with the 1,000 kilogram margin we took, that you will be heavier during the takeoff, you of course have to do some new takeoff calculations. So these are some important things to consider. Here we have something called cruise CG. Now in real life this would be a bit of a higher value. Yeah, again, with a proper load sheet you will get some information about this. Usually it's around 30, or maybe to give a quick rough estimation, it gives a CG of 2765. So we can kind of maybe do that -1 and then enter that right here. So kind of have an estimation of the cruise CG. It helps to calculate maximum altitudes and step climbs, etc. Okay, so that is done. We have set the current zero fuel weight and the current cruise CG. Thrust limit, we've already entered the assumed temperature as calculated before, and right now in the current conditions gives 92.9. You can see as the temperature changes, it also changes the N1 value, so do cross-check that maybe. It's been I have had some lunch before recording this session, but if there's a huge temperature change, of course you also have to do some new calculations, but in this case it should be fine. Then we go to takeoff. Here we have the CG. If you click on this line select key, it will give you the latest CG. We'll just enter it and it would round it off, in this case to 28%. Okay, so now we have all the weight and balance information basically of the aircraft loaded in the CDU right here. So now we can also enter the associated V speeds that we calculated, and as you can see we have a V speed of V1, which this is the decision speed at which we're going to decide whether we continue the takeoff or not. Our rotation speed, and V2 is the safe climbing speed on one engine. So 169, 175 and 179. So we'll just enter that, 169, 175 and 179, and as you can see it's quite corresponding. If you would have any you know, other runway conditions or other winds, you know, it would maybe be a little bit different, but as you can see the values are correct here. So that is all completed, and now we have completed the FMC pre-flight procedure basically. Alright, so we can slowly get started with the before start flow, and this is to get the aircraft ready for the startup and pushback basically. Okay, so make sure that all the windows are closed, doors are closed at this point of course, and also the flight deck door is closed. We're going to turn the seatbelt onto auto. Usually, as you can hear in the background, it turns on. If you're flying from a higher altitude airport, you want to put it to on, or if you expect turbulence, you want to put it to on, because usually it will automatically switch off in the auto mode at around 10,000 feet, or depending on airplane configuration. It differs a little bit per airline. For now we can leave it on auto. We're departing from a sea level airport and the weather is good enough, so that should be no problem. Okay. So we're going to pressurize. The ground crew has installed a bypass pin, and this is important because before we pressurize anything, we don't want any nose gear movement or things that could hurt the ground people on downstairs, because if you put on hydraulic power, it really has quite a bit of force. So a bypass pin needs to be installed in the nose gear in order to disconnect the steering tiller hydraulic force on the nose gear, allowing us to safely apply hydraulic power with the towing truck connected to the aircraft. On the 777 it's a little bit peculiar, the flow that we're going to go through now, so I'll just explain. We're going to turn the right electric demand pump on first, and the reason for that being there is a chance of hydraulic quantity moving from one system to the other if you do it another way around. And this goes through the parking brake system, through the braking system. It's a little bit complicated, but the default procedure is to turn the right electric demand pump on first, on auto. The fault light extinguishes, and then we can turn on the C1 and C2 electric primary pumps, and then we can turn on the rest of the hydraulic pumps safely. As you can see, all the fault lights extinguishes except for this one right now. This one is being load shed. This is quite normal at this stage. The airplane basically during the startup process will load shed some of the systems, as we'll see as we start the engine, so it's normal that the fault light is still illuminated on this one at this stage. Okay, so go down, seatbelt is already on. Then the fuel pumps, again, we turn them on. Also this one, even though the APU has already been using it in the background, we have to physically also turn these fuel pumps on as well. And in the center pumps you would get an ICAS message, fuel in center, and that indicates well, there's fuel in the center tanks as well, so we have to turn those pumps on as well. Pressure lights are being extinguished, so except for this one, and that's also correct. This is also simulated in the background. This pump is at the moment being load shed by the aircraft system logic. Okay, so this is a normal site. I'm going to turn on the beacon lights as well. There we go. Then we go down, and we're going to do a little recall to make sure we have the expected messages on the ICAS. In this case, engine shutdown, TCAS off are normal. So we're going to cancel that, and we're going to turn on the transponder. Before starting pushback, you want to put this to XPDR. It will turn the transponder on for ATC to see us, but we will not be using the TCAS functions yet. So this is a good position. So this is kind of the first officer flow of things. Now the captain, would of course deal with the load sheet and with the first officer together, enter all the relevant data. It's good to keep the takeoff reference page open on the side of the pilot flying, and in here you can, for example, leave the legs page open. Next we're going to go to the MCP. We're just going to set some of the values that we've calculated. So V2 is going to be 179er. That's also what you're going to enter here in the speed window of the MCP. I'm going to be flying this departure with LNAV and VNAV. And if you do this procedure right now, you could of course already do this before, but it's kind of a nice confirmation that you've both read the load sheets. And of course with that also make sure that the runway heading are correct and the altitude, initial altitude are correct, as we already set during the pre-flight. And then we also have to set a trim. The aircraft comes up with a trim value of 5.25 required for takeoff. And you can use the electric trim switches if you've programmed that to your flight sim yoke, whatever you use. You can use these to set the trim to 5.25 units. So it's very slow to move, it's quite realistic. It takes a while to get to the value that you want, but now the trim is set, so that is good to go. So that kind of completes the before start flow, and now we would be ready for the startup and pushback. So in real life this is kind of an it can be a bit of a chaotic phase. Sometimes different procedures are done at different times or in a little bit of a different order. But it's important, you know, especially as you do this for the first time, just to take your time. You know, in real life you probably would not leave the beacon light on that long without moving. But it's just a nice way to just, first follow the first officer flow. You know, turn on the hydraulics, seat belts, fuel pumps, beacon lights, give a little recall check, and then the TCAS. And then do the captain flow by setting the MCP after confirming the load sheet and setting the trim, and also the trims here as well, the rudder and the aileron trim. Make sure you include them in your scan flow. So let's say that the cabin is ready and the cabin secure is given. The gate is removed, the ground crew is ready to go.
Release parking brakes.
Again, they want us to release parking brakes. The bypass pin has been inserted. We've done all the checklists, we've done all the flows, so now we're pretty much ready to go. So we can do the before start checklist. Before start checklist, again, just click on the checklist button. It will automatically pop up with the next normal checklist in sequence. The flight deck door, well, it's closed and locked. MCP V2 179er, heading 236 and altitude flight level 60. Takeoff speeds, we have V1 169er, rotate 175 and V2 179er, also set here. CDU pre-flight is completed, trim 5.25 units and 0 rudder trim and 0 aileron trim. There we go. And the taxi and takeoff briefing, let's say we did that before, is completed. Beacon light is already ticked off, as you can see. It completes the before start checklist. So let's open up the engine page again, so we're ready for engine start, and we're slowly ready to start going. So if you're flying on VATSIM, I will just include some of the phraseology here. Now we would go to the Schiphol planner frequency, in this case at this airport. It's the frequency we were given, let's say via the data link clearance that we got. So let's just report fully ready, and then of course when you're flying on VATSIM, make sure you actually are fully ready to go, ready to release the parking brakes and start to push back. Do not wait too long after you receive that clearance, okay? So let's report fully ready. Schiphol planner KLM 601 at Echo 19er fully ready. KLM 601, information Bravo, QNH 1006, hold position and contact ground on 121.805. QNH 1006, information Bravo, holding position and ground 121.805, KLM 601. Okay, so we got a next frequency, we're going to tune that in. And here we're going to ask for pushback. Schiphol ground, good morning, KLM 601, stand Echo 19er, ready for startup and pushback. KLM 601, Schiphol ground, good morning, startup and pushback approved. Startup and pushback approved, KLM 601. So we're ready to go. One more thing I have to do is to remove the wheel chocks. There we go. Of course, otherwise it's going to be hard to move. So again, we got the clearance, the before start checklist is completed. If you did not turn on the beacon light by now, of course now you would have to turn it on to complete the before start checklist and to alert the ground crew that the airplane is about to move and to start the engines. So we're good to go. We have the secondary engine indications open here on the lower display, and yeah, so we're ready to go. We're gonna release the parking brakes.
Commencing push. All engines clear. Start at will.
Alright, we already got the all engines clear message, so the airplane will now push back. Now in real life you would now give the command to the cabin crew via the PA system to arm the slides, and this allows the slides to be armed, ready for operation in case of an emergency evacuation. Let's see, I've not seen it actually work on the PMDG 777 yet, so you can also do that manually, because you want to see the doors auto indication right here. So let's take a look. have his actions, doors, and then arm all doors. There we go. And you'll see that it changes to doors auto, so that's correct. Okay, so the aircraft is pushing back nicely. We've already received the start clearance from the pushback truck to start the engines. Everything is clear around the airplane, so we can start the start sequence right now. So we are going to start the right engine first. Probably depends a little bit on the airline which you will start first. It doesn't really matter. But we're going to start the right engine first, and we're going to do so by moving the engine start selector to start, and then we're going to move the fuel control switch of the right engine to on to run. We do not have to wait for that fuel control switch or anything. We're just going to turn it on immediately. So we're going to move this one to start. We do not have to turn off any packs or anything. So fuel control switch right to run, and now the engine is going to be started. Now the auto start system is going to take over the rest, but what you do have to monitor as you put the fuel control switch to run is, apart from listening to the beautiful engine noise, monitor the oil pressure. Make sure that the oil pressure is actually rising with that, otherwise you might need to import the engine start. But as you can see, we have nice oil pressure is rising slowly.
Please set parking brakes.
So we'll let the engine start do its thing. We have stopped. Always verify that the aircraft is actually stopped before setting the parking brake for the pushback truck. So let's set them right now.
Unlocking gear.
Okay. So as you can see, the engines are starting up nicely. All automatic. Again, no, we don't have to turn off any packs or anything like on the 737 if you're used to that one. There we go, and the engine has stabilized, and once the red EGT limit line is disappeared, it indicates that the engine has stabilized. Okay. Alright, so right engine has successfully started, and then we can start the left engine. So again, we're going to go to the overhead panel, start the left engine,
Tow track disconnected.
fuel control
Bypass
switch
pin
on the
removed.
left side to run, and again we're going to monitor for the same values,
Left
oil
is
pressure
clear,
rising.
right is clear.
See some of the load shedding that took place. Center pump, the right one is already working again, so that's all in order. In the end, we don't want to see any of those amber lights on the overhead panel, but we'll take a look at that in a moment. Pushback truck is being removed in the meantime. Lovely engine sounds. Okay, the ground crew shows the bypass pin, so that's good. The marshaller, thank you for showing it. It shows that we can operate the nose gear ourselves right now, so we can actually steer the airplane on the ground. Again, the EGT red line is removed and the engine stabilizes, so we have successfully started the engines. Alright, so now that the engines have stabilized, we can take a look at the overhead panel. As you can see, most lights are extinguished except for the packs. It might take a little while for the packs to come alive. But we're gonna turn off the APU. We don't need it anymore. All the, as you can see, the engine generators have successfully taken over all the responsibilities regarding that. So we're gonna turn the APU off. There we go. Just kind of check column by column again. You can kind of go through the panel if you want to again, just to make sure everything is in the right order. But in principle, we can go all the way to the engine NTIs. Engine NTIs, if there are icy conditions, you know, with temperature below 10 degrees and visible moisture outside, you will turn the engine NTIs on the ground. Wing NTIs is only used in the air and doesn't work on the ground, even if you turn it on. So, but there are no icy conditions, so we can leave the engine NTIs to auto, to automatically operate once in the air. Alright, in the meantime the packs have taken over, so that's good. We're going to do another recall check. TCAS off, that's expected, so that's normal. We're going to set the flaps for takeoff, so flaps 5. There we go. And as the engines have started, we can turn off the secondary engine indications. Okay, so we'll just wait for the flaps. Before you do any flight control check, just make sure everything is clear, all the ground equipment is clear, there's nobody bothering with the airplane anymore. So we can do now a little bit of a flight control check. And the purpose of the flight control check is really to just check the freedom of movement of the flight controls by pushing the yoke nicely forward and of course all the way back. Real life especially, you have to do that quite slowly, because if you do this way too quickly, it will actually cause quite a lot of shaking in the airplane because of the effect on the stabilizer. So do it just slowly and deliberately. Make sure there's enough freedom of movement. Make sure that the controls nicely center back to their neutral position. And also it's nice to make sure there's nothing jammed and no ATIS messages pop up regarding the flight controls, for example. Next we check the rudder. You would in real life also make sure that you hold the tiller in that case to prevent nose gear movements. So we're going to move them in both directions. Again, same thing, freedom of movement, and make sure that they turn nicely to center. Alright, so that is done. Now we can move to the before taxi checklist. Again, by just clicking the checklist key, we can cycle to the before taxi checklist. The ATIS is all on auto, as I said before. Recall we already checked before. Auto brake, as again, already ticked off. The flight controls have been checked, and the ground equipment. Just make sure that everything around you is clear. So the ground equipment is clear, and the before taxi checklist is completed. So there you go. We have successfully started up the Boeing 777 and are ready for flight right now. And as you can see, it is quite a bit of work, especially as you get to know the airplane for the first time. If you're coming from the 737, it's quite getting used to you know, all the things that are done automatically on this airplane compared to that aircraft. It's very nice to just take your time with all the systems and then slowly explore it. So now you would of course request some taxi clearance, turn on the taxi lights, release the parking brakes. There we go. And again, as you release the parking brake, make sure it's actually turned off on the ATIS, and then check your left and your right, and then you would be able to start taxi for your lovely departure for a nice little flight to Los Angeles International Airport. So there you go. I hope you enjoyed this cold and dark startup tutorial here on the AviationPro channel. Hope you learned something. Again, with a little bit of a flavor of real life, but some things are of course done a little bit different in real life, but hopefully this gets you on the way with the 777. It's a great airplane. It's very nice to learn about all the systems and the procedures on board the airplane, and just to take your time, especially as you're doing a long haul flight, for example on the VATSIM network. It's really great fun. So if you liked this video, make sure you leave a like, and if you want to stay tuned for more videos on the 777, I'll probably do a VATSIM full flight sometime later with this beautiful aircraft, so stay tuned for that. If you appreciated this tutorial, I would very much appreciate your support. If you could leave some sort of support by buying me a coffee, there's some links in the description for the different ways of doing that. And of course, you can of course also become a member if you want to of the AviationPro channel with some extra monthly live full flights here on the channel. For now, I wish you some happy flying hours in the beautiful Boeing 777 and Microsoft Flight Simulator. Have some fun, make sure you study it well, and there's a lot to learn, so I'm sure I'm gonna have a lot of fun with it. For now, have some fun, and I will see you in the virtual skies.